funny we should talk about this with the $1.5 billion lottery? And I'm sure, you just don't understand. You might as well take your $2 and buy yourself a present, because the probability of you winning it, or the odds, the chances of you winning it are so small. You probably have a lot higher likelihood of actually dying today than you do with winning the lottery. I mean, that's 1 in 290 million. There's maybe 350 million people in the entire United States. So that means one person in the United States maybe a winner. Even last time nobody won it at all. So I mean the probability, the chances, all that.
It's a machine. It picks out numbers, isn't it?
Well, you can pick your own or let the machine pick, but either way, I mean, it's just, there's a reason why people make money at it, or they make money at it, is because the chances of you winning it are so infinitesimally small. It's hard to conceive all of that. I could tell you, Drew, I could have 20 numbers. I could probably sit here for 3 weeks and have my own little lottery and only have numbers go up to 20 and have you try to pick 6 of them. And I'll bet we could play for probably the rest of the year. And nobody in here would pick the same 5 numbers that I pick out of 20. I'll bet. I'd like to do it, but I'm not. Anyways, what is probability? Probability is the likeliness of something happening. And when we talk about probability, children, make sure probability we list as a fraction, generally speaking. And if you were to draw that fraction on a line, okay, if something has a 0 probability, okay, basically you're saying that that is impossible to happen. Okay, it's not going to happen, it's impossible. If something has a probability of 1, for example, the probability that you'll get a math assignment, that means it's certain. It will for sure happen. The probability that today is Wednesday is 1. Okay. And then you've got all the fractions in between there. Okay. You've got this, the fraction 1/2, basically says it is as likely as not to happen. As likely as not. Okay, and then when you get to the fractions that are greater than 1/2, we call that just being likely. And that doesn't mean it's going to happen, but it's likely to. And the fractions here are unlikely. And again, here's the deal, people. If you want to know where the fraction of probability for you winning the lottery, I couldn't draw a line small enough, close enough to 0 for that to be your fraction, because it's 1 over 290 million. What is 1/290 millionth? I can't even put a line close enough to 0 to show that for your probability. That's how close to almost impossible it is. You probably have a higher probability of finding $1 billion than you do of actually winning it. And they glorify it on TV because they say somebody has to win, and that's true. That's true. It's just somebody has to become president too, but that's probably not going to be one of you guys. Maybe a little bit. And here is what, tell you what, you wanna just kind of get yourself into the feeling of what it would be like to win the lottery. They say the probability of that, the chances or the odds of that happening are the same thing. Tonight when you go home, take a penny. They said the probability or the chances of you winning the lottery is the same probability as you taking a penny and flipping a head 28 times in a row. So if you're bored tonight, grab yourself a penny and you flip it all night long and tell me how many heads you get to in a row. Like if you flip 5 and then you get a tail start over and then see, if you get 28, then I go out and play that lottery because that's about the same odds of you winning that. Now, a couple other things with that. We need to, we need to flip to a new, we need to flip to a new piece of paper. And on top of that, like sample space. This all deals with probability, but you can't put this under probability because then if I ask you for sample space, you don't know where to look. The sample space, if they ask you for something like that, that is all the possible outcomes. Okay, so if I said, give the sample space for flipping a coin twice. Well, let's look at the possibilities. When you flip a coin on the first flip, you could get a head or a tail, correct? After you flip a coin once, then you flip it again. This is the first time. Then the second time, you flip it again. Well, if you got a head the first time, the possibilities the second time is after that head, you'll get another head or a tail. Or if you flipped that tail first, you'd also have a chance of getting a head or a tail first. So these are all your combinations, which we call our sample space. You could flip 2 heads, or you could flip a head and a tail, or you could flip a tail and a head, or you could flip 2 tails. This right here is your sample space. It is all the possibilities. Another example would be if you had a spinner that was split into 4 different parts labeled 1, 2, 3, and 4. Your sample space would be just 1, 2, 3, and 4. So that's all they're asking. And the reason why you need to know sample space is because sample space helps you figure out probability. If I asked you the probability of flipping a head twice in a row, probability, I suppose we should probably talk about that. Probability is, where did it go? Probability is, when you define probability, you make it a fraction. On the bottom is the total sample space. And on top is how many of that sample space is the one that you want. How many desired, one desired. So going back to my flipping of my coin, I had a head, a head tail, a tail head, and a tail tail. If I asked you the probability of flipping a head and a head, on the bottom of the fraction is how many things were in the sample space, 4. And how many of those 4 were head? Just 1. You have a 1/4 chance, you can't say that, 1/4 probability of flipping 2 heads. What is the probability of flipping 1 head and 1 tail? Elijah?
1/4.
Well, let's look at our sample space. We still have 4 there, right? But this has 1 head and 1 tail, and that has 1 head and 1 tail. So there's actually 2. 2 out of the 4 things is flipping 1 head and 1 tail, so it's actually 1/2. Half the time you should do that. Probability of flipping 2 tails, just 1 out of 4. Or how about this? You're probably familiar with a deck of cards. What is the probability of picking the Jack of Hearts on the deck of cards? By the way, that's how we talk probability, we use a capital letter P. Inside the parentheses is what we want. How many cards are in a deck of cards, Manny? 52. How many of those 52 are jacks of hearts? Just one. So your probability is 1 in 52. You would have a higher probability of me just having a deck of cards and me saying, okay, I want you to draw the jack of hearts and then the king of clubs and then the queen of spades and then the nine of diamonds all in a row than you would have won in the lottery. And that would almost never happen if you could sit there with 52 cards. How about this? What would be the probability just of drawing a jack? That's different because we still have 52 cards, but I'm not just saying the jack of hearts, I'm saying any jack, which would be, Emily?
4.
Like 4 out of 52, which actually reduces down to 1/13. Now watch, 52 can be divided by 4. What is the probability of drawing a 2 or a 7? Well, you still have 52 decks of the cards, or cards in the deck. How many 2s and 7s are there in the deck? Isabel? 8 of them. And again, we reduce it to 2/13. Okay, perfect. Now, take out another blank piece of paper, and on top write the word chance. You sometimes get those mixed up, chance and probability mixed up. Chance is pretty simple. Chance really is the same thing as probability. Same as probability. T, comma, but in percent form. In percent form. And a good way to remember that is, if you listen to the news ever or weatherman, they always give you the chance of rain. They don't ever say probability of rain. And always that chance is as a percent. There's a 30% chance that it's going to rain today. Okay? So, the probability, or the chance, going back to flipping those coins, the chance of flipping 2 heads in a row as a probability it was 1/4, but as chance we'd have to say the chance of it happening is about
25%.
25%. If the weatherman tells you there's a 40% chance of rain, what really does that mean? Is it going to rain or isn't it going to rain? Keith, it's slightly unlikely, but still 40% means there's a chance. It's probably unlikely, but who knows? If it's 50%, then it's kind of as likely as not, and that's weathermen make their money on that sort of thing. And then last piece of notepaper, please, right here. Last piece of notepaper today